Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating. Here's an overview for episode number 4. In earlier episodes, we talked about part 1, scope organization, 2, weld repairs. 3, we'll continue our discussions on weld repairs. And part 4, there'll be discussions on non-metallic and bonded repairs. And 5, there's pressure tightness of piping and equipment. And we're going to continue with the second half of mechanical repairs. Continuing with our second half of the 300 series, or part 3 of PCC-2. Article 306, mechanical clamp repairs. The essential components of a clamp repair are 2 half shells, and they can be a number of different shapes. The one over here is one for a drain, but it consists basically of 2 half shells, top and bottom, and then you have a gasket, which is required for the seal, and then the sealing forces are provided by bolting. Now ASME has 2 types of clamps, or 2 purposes, and they can be one or the other or both. And so the first one is called a seal repair for leaking components, and that's non-structural in nature, so it's not intended to carry the weight of the pipe. It's just providing leak repair. The second is called reinforcement of damaged components, so that's what can be considered a structural repair. Secondly, the scope for these clamps is quite varied. They can be used for flanges, valves, fittings, branches, vents, and drains. And the one shown below here is an example of a drain clamp. They're available as catalog items. And if you want to know more, send me an email. I can help you with that. Or you can make them custom. And there's a few warnings that ASME has with clamps. So they cite higher corrosion rates have been experienced because of the clamp, and I believe it's mostly to do with underside corrosion between the clamp and the pipe, and also dew point corrosion. Because this is a very thick component, it actually acts as a bit of a radiator, and it'll cool the pipe, and then you could have a lot of condensate buildup, which increases the corrosion rates. And also you're going to have a lot of residual stresses because you're clamping down on this pipe and you're restricting the pipe from growing. So you got to really watch out for high temperature services. Article 307 has to do with straightening or alignment bending. And the bending processes discussed in this article are related to bending processes, which includes hot bending, which is by definition above the lower critical temperature, cold bending, and a combination of heating and cooling. And some considerations that they take into account are piping stresses and reaction loads, because there's some spring back, and this is where stress analysis would be required. They look at issues associated with buckling when you bend the pipe, and they look at the materials. There's a caveat about creep enhanced materials like P5B materials have issues. And so there's some warnings there, and there's discussions about linings and coatings. If you have a polymer lined pipe, then there's issues associated with that. But they also this is a really excellent standard called PFI ES24, which we've used for induction bended piping, and it's probably the best standard that I've ever seen for use for bending processes. So, and it's mentioned in PCC-2 on their roadmap, which is in the reference section. Next is Article 308, damaged anchors in concrete. So this is a post-installed anchor bolt installation issue. And this happens as plants get older. So let's just go through a quick overview of the type of anchors. I'm actually quite surprised that ASME goes into this, but what's interesting is they reference a lot of other specs, so it's a pretty good roadmap, and there's some good advice in there. Hooked bars are the first type of anchor you'll find. Next is called a bolt, and the third is called a threaded bar with nut. And basically you have your anchor assembly is shown over here to the right, and basically your anchor bolt is right there, and it's embedded into the concrete. And so 99% of the time you're installing the anchor with the concrete, because that's where you get the most strength. If you install anchor bolts post concrete install, they're not as strong, and then you have to use something called an epoxy type of anchor. And if you want to another video with regards to that, that'd be great. Or we're also looking if someone wants to sponsor that would be fantastic. So let's continue here. So here's another base here. So you can see we talked about, here's your anchor post. It's going to experience a lot of bending and some uplift as well. So there's these anchor bolts here, and then sometimes they'll put grouting underneath it, or sometimes not, and that depends on the designer. I tend to think that you'd want to put grouting to keep the corrosion out away from the anchor bolts. So again, these anchors experience a lot of bending moments and uplift. They don't really experience the compression load to the same extent. Those aren't the problems so much. So here's some strategies. They have some great strategies. They have weld repair, but I put in red here. Careful of heat-treated anchors. Second, rod extensions is another strategy that they go through. Replacement, this is where you just replace it outright, and there's some interesting manufacturers out there that provide replacement anchor bolts. You can abandon in place, and then you can drill another one or another two anchor bolts sort of adjacent, like over here. And here's a strategy, so you have room, and then you can install anchor bolts on those locations. So those are the basically what's in your toolbox for doing anchor, mechanical anchor repairs. Let's continue. So there's, with part 3, basically there's 309 and 310. And these, at the time of creation of these videos, were not available. They're in progress. The first one was called Valves with Pressure Seal Type Bonnets. ASME committee is apparently working on those. And also hot bolting is not available at this time, but it is also in progress. Article 311 has to do with hot and half bolting removal procedures. This is where you're removing and replacing bolts while the unit is online. I have never done that before. If someone would share that experience, I would be very interested in hearing that. So basically, hot bolting, let's go through that. So basically, we're reducing the pressure to, the rule of thumb is less than 50% of P max. But ASME says you need to calculate that. But the rule of thumb is that you need to be at least that. So you're supposed to replace one bolt at a time. and it's sequential. Okay, and each bolt, the fourth element actually is each replaced bolt is fully tensioned before you go to the next one. And that's what I have to say about that. Part 2 of 311 is the half bolting. We just talked about hot bolting. Let's talk about half bolting. Its slang terms are skip bolting or odd bolting. And this is the removal of every other bolt and half of the bolts during the plant outage. And the pressurization is required at close to atmosphere. The next part is Article 312. It's actually quite an extensive write-up in ASME. It has to do with the inspection, repair of shell and tube exchangers, and it has a lot of parts. Over the years, this is something a maintenance engineer will spend a lot of time on, dealing with heat exchanger issues. So there are tubes and tube bundles, a section for that. This section with tube sheets, tube sheet to tube sheet joints, bimetallic shell to tube sheet welds, and channel and other pressure containing components. Let's continue our discussions about 312 repairs. Now it talks about cleaning options. The article has a section on that. It has sections on plugging and ferrule and sleeving, and includes strategies such as welding, roller expansion, explosive bonding, hydraulic expansion. Over here to the right, I have a diagram of a ferruling where you put the sleeve insert, and then that's how ferrules work. Okay. The next part is tube pulling, and we have repair in place strategies, and which includes overlay machining strategy, re-expanding the joints, sleeve welding, and which also, if you look at Articles 201 and 202, there's other repair in place strategies. And it goes through some examination recommendations, which is the ITP. The last section of mechanical repairs, part 3. It's called Article 313, crimping of metallic pipe. So basically, pipe isolation is done by plastically deforming the pipe cross section to restrict the flow. And there are a couple types, or a few types. There's double crimps, where you crimp, and then on either side, like as shown here on A and then on B, and then you inject at C, like some kind of sealant. The other ones are called single crimp and an isolation valve, and the third strategy is called a single crimp. So that concludes article or part 3 of mechanical repairs. I hope you find that interesting. I'm looking forward to your comments, and please subscribe. I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.